We're going to talk about three things today. How do I collaborate with my security team to deploy serverless into production? How do I aggregate data that lives in disparate systems across the organization? And how do we deploy, monitor, and run our serverless applications? G'day, I'm Scott. We're from a small set of rocks in the South Pacific called New Zealand, where video rental stores still exist, and our national symbol is a flightless bird called the kiwi. I work for a AWS consulting partner called API Talent. We help our customers do great business, I guess. I'm really excited to be here with Simon from Xero, and we're going to share two serverless implementations. So recently we've been collaborating with our security team to make sure our solutions are secure. And so I'm going to tell you a bit of story about that, and then Simon's going to take over and tell us about his program of work.
Hey team, I'm Simon. I'm an integration engineer at Xero. Xero develops the world's leading accounting software for small businesses. We have over 700,000 subscriptions across 180 different countries. We were born natively in the cloud 10 years ago and have just recently finished a huge migration from Rackspace to AWS. Xero is a really fun place to work. Here we have Scott and I hacking away at serverless and our onesies, along with a bunch of other people from Xero to raise some awareness for the local ambulance service. So I'm going to hand over to Scott now, and he's going to tell you a bit about the security journey.
Thanks, bud. All right, so in New Zealand, a large enterprise to us is not exactly a large enterprise by global standards. In 2015, we only had 350 companies who are larger than 500 employees. Today, our largest company has 20,000 employees globally. If you compare this to the US Defense Department, they employ 3.2 million. That's almost the size of our entire population. I joined Xero to help with a product called ZeroCard. ZeroCard brings together information about Xero's customer behavior, and it's all collected into a big relational data set. We use this data to drive analytics for the marketing team, so they can run campaigns for new customers. And we also use the data to drive the ZeroCard app that we're building. So our customer experience team is going to use this app when they're talking to customers on the phone. They'll be able to pull up a user and see all their connected accounting practices and organizations, see all the features that they've used in the Xero app. And this is like hugely valuable information when they're talking to the customer on the phone. So to build the app, we needed an API to present the entity relationships in a standard and well-defined way. We also needed some infrastructure to deploy it to. So 12 months ago, I would have approached it by rolling out a standard 3-tier architecture. So we've got some EC2 instances and auto-scale groups there. At the top, we've got our presentation layer with web servers and caching. In the middle, we've got processing layer with the big, heavy EC2 instances doing the number crunching. And at the bottom there, we've got our databases that persist the business data. So this is what the design would have looked like 12 months ago. I'd just been reading up on function as a service, and it sounded really cool. It seemed like there was something a bit different we could do here at Xero. So I was reading up I found a video about the JAWS framework, and that led me to the serverless framework. And what I liked about this framework was you could quickly stand up an API and start to surface some of that really valuable ZeroCard data. Using this framework, instead of planning for an implementation years away, we could use serverless and deploy now. Now, this meant for a really happy project manager because he could see the results straight away. And it also meant for really excited data scientists because they could see their data model being used in cool ways. If you've ever seen an excited data scientist, you'll agree it's quite cool. It's a bit scary, but... So another cool thing I liked about the framework was it really put Lambda at the center of things. And at Xero, we love Lambda. So I was stoked that we could keep using it and keep getting those low cost and operational benefits that Lambda's so good at. So we landed on this. And you would have seen this before because it's a standard serverless architecture pattern. I'm just going to go through some of the components in a little bit of detail. So over the left there, we've got our trusted API consumers, and they send requests to Amazon API Gateway. API Gateway is protected by the Xero Identity Service. And then over on the right-hand side, we've got our back-end Lambdas in our VPC. Some of those Lambdas connect to an RDS database, and some of them don't. And the Lambdas are kind of arranged in a microservices arrangement, which means that one Lambda is responsible for one piece of functionality for one API endpoint. We've also got some operational Lambdas in there that do some cool tasks for us. Like, we've got one in there that pulls our logs from CloudWatch logs and sends them to our centralized logging tool. We've got another one in there that pulls metrics from all around the place and sends that to our monitoring tool so we can do proactive data monitoring, mostly on data quality, which is really useful. So we also needed some infrastructure. Here it is. Looks pretty easy. We went with a single-page application built in React and Redux for the Xero Card app. And we deploy that application using our in-house CI tools to an S3 bucket. And we've set CloudFront on top of that to get, so we could use a custom SSL certificate and get the performance benefits out of edge caching and compression. So in making sure we were secure by design from day one, we engaged our cloud security team to come work with us. And they said, tell us more. They were quite excited because they saw these designs as a way to increase their pace of innovation and security. And they wanted to create a design pattern for serverless that was useful for Xero as a whole. Now, just like many organizations, Xero had a number of server-based security mechanisms. And these are really good when you're running servers, but they don't all apply when you're running serverless architectures. So when you start talking about the accelerated pace of security innovation and the next wave of technology growth, it's really important that you involve all your teams, including the cloud security team and project teams, in your solution design. After all, your application and security are not two different things. They're fully entwined. So why wouldn't your teams be? And at some point, you still have to ask, can we do it? So is there a place for serverless at Xero? Should we innovate and support this new thing? And of course, the answer for serverless is hell yes. Like, it's awesome. Let's make it an awesome solution. So I went and sat down with the stakeholders. The cloud security team, the architecture team, management team, data team, integration team. And we all had a chat about it, really. And what was cool was they all were actually really interested in the solution because they could see the benefits. And they realized that it didn't fit their current model. So the traditional security mechanisms had been replaced in an AWS world with mechanisms that were new and unfamiliar to the team. Now, I must emphasize here that the traditional security mechanisms are still good. They still do what they're meant to do. But maybe they don't work with serverless architectures how we would like. So when you're presented with something new, it's really hard to automatically trust that new thing, and that's essentially what we're asking of the security team. So how do you get a whole company to trust something new that they haven't used before? Well, you go to meetings, lots of them. Not just meetings, educational sessions including drawing on whiteboards, proof of concepts with documentation, and about 1 million emails. We collaborated on the solution down to every single last detail. We sought expert advice from Amazon Web Services, who sent two solution architects and the national sales manager to come sit down with us and hear a walkthrough of our approach. We came up with a way for everyone to be happy that our solution was secure without having to throw our original ideas away, which was really cool. While those details are quite technical, the point I'm making here is it takes time to work together to create something new. You have to collaborate and go on the journey together. And then our chief platform officer said, yes, green light. We had a solution that worked for us. We had established a pattern that could be reused around the business, and everyone was happy. So why am I telling this? Why does my story matter? Because you need to start your journey with your enterprise early. It takes time to build something new. Engage your security team, your architecture team, and the team who has ownership of the data itself. And your pitch to them should benefit the company as a whole, not just your satellite project. So in the end, I think there is a place for serverless in the enterprise. So I'd just like to hand over to Simon, who's going to tell us about another serverless implementation. Here you go, mate.
Cheers. From my experience in integration, there are things that suck. For example, managing data persistence, network connectivity, delivery speed and dev startup time, and bloated code repositories. Now, before I dig into these, I'm just going to give you guys a bit of a history or background of integration at Xero. When I first started at Xero, the only integration that was in place was point-to-point. Now, obviously, this isn't scalable. So we had to, when we bought a new SaaS product, we had to relook and reevaluate the integrations that we had in place and how we could get this all working. So I came in and recommended a SaaS middleware platform, and we implemented a few patterns and models using this. One of the first ones we put in was having to do two-way syncing, so keeping two products real-time in sync. No matter where you go, doing this at an application layer can be quite tricky. Next up was a event stream polling sort of mechanism. This was complicated due to the sheer quantity of data involved. We had multiple applications feeding in all of their changes into an event stream, and then the integration platform picking these up and writing them. Next up was a lightweight API. We had to use the we used the integration platform to facilitate lightweight API calls across multiple applications or SaaS products or things that didn't natively support easy APIs. Now, the complex integrations the middleware platform really excelled at. It did a really good job at handling these complex transformations in large quantities of data. But on the flip side, the lightweight APIs, it was a bit overkill. You didn't want to have to stand up an entire ESB just to facilitate a few API calls. So that sort of sums up the history and leads me on to the next big program of work going on at Xero, the partner program. The partner program is made up of a whole raft of smaller teams and smaller pieces all coming together to make this one big program of work. One of the integral parts of this program of work is the advisor directory rebuild. The advisor directory is a place where small businesses can go to browse accounting firms and accountants that have and use Xero. For example, if you were a London-based small business and you wanted to find a London-based accounting firm, then you'd jump on here to find them. Or if you're looking for a payroll specialist, then you'd go here to find them. Now, the content of the current advisor directory only makes up about a third of the content of the new advisor directory. So as you can imagine, that's quite a lot of new data that we need to source. And unfortunately, the advisor directory was not part of our existing integration stack, which means we weren't able to leverage any of the integrations that we had in place. One of the key problems facing us was the location of the data. It existed in multiple systems managed by multiple different teams. Not just that, but we also had to facilitate real-time API calls as well as background refreshing of that same data as it was being fronted by a web page. Previously, this would have been an integration nightmare. The solution? An aggregation engine. An engine used to consolidate and bring together all these various data sets into one single aggregated view. Now I'm going to run through the problems that I brought up at the start and why we chose to go down the path of serverless. The first problem was data persistence and message state management. The middleware platform didn't allow us to easily stand up data persistence, so we chose to go with DynamoDB, a lightweight NoSQL database that fit really well with the architecture that we were going with. The serverless framework allowed us to handle all of our CloudFormation scripts and stand up the DynamoDB instances very easily, and kept that in the same repository as our code. We also hooked up Lambdas very easily using serverless to DynamoDB in the event stream mechanism to consume events that came straight off there. Adding to that diagram, I've added in Kinesis. Kinesis is a very powerful AWS service, can do a lot of things, but specifically what we were using it for was sort of a publish-subscribe queuing mechanism. So in this scenario, you would have an API request come in, place it on the Kinesis stream, then get picked up by another Lambda, which would go out and call a different API, transform that data, and then write it back to the database. Or it would put it on another Kinesis stream and trigger off that whole process again. So not only did we use Kinesis event sources, but we also had scheduled event sources that would trigger off a Lambda to go and call a custom event stream. Next up was network zones. Now, a lot of the APIs that we were calling were in various different VPCs and different network zones. And typically, with your middleware platform, you'd have to open up all these routes and paths to that one whole platform. Fortunately, with the serverless, we were able to deploy the Lambdas in the different VPCs, but still all work together seamlessly to create the aggregation engine. Here is the simplified version of the aggregation engine. The full one couldn't fit on here. Quite a few components. We've got 39 Lambdas, which do all sorts of different things, ranging from handling API requests to consuming Kinesis streams and doing various transformations. We've got 13 APIs or API resource endpoints and 23 event source endpoints. And these are your DynamoDB streams, Kinesis streams, and scheduled streams. Next up with delivery speed. Now, often when you start a new project, you have dependencies on other teams to do things for you. For example, you might need a DBA team to build your database and manage that, or an infrastructure team to stand up servers and open up network routes. Fortunately, using the serverless, we could just stand up Lambdas very easily and get them deployed all by ourselves. Dev startup time. At serverless version 0.5.6, I actually had a Windows laptop and did not have very good support for Windows. So I had to stand up a VM and SSH to this and get all that going. But luckily, all of my colleagues have Mac laptops, so onboarding someone was a lot easier. Had them up and running and doing serverless stuff in about a day. Bulky code repositories. Now, nothing's worse than joining a new team, jumping into the Git repo, and it's just an absolute mess. Just comments that don't make any sense, just huge commits. Typically, with your middleware platform, you'd be using quite a heavy programming language like Java or .NET, or some proprietary framework that they offer. Fortunately, with Lambda and serverless, we were able to, choose from various programming languages, we chose a lighter weight option, which allowed us to keep our code repositories very small and capsulized. Operations. So obviously we already had a whole bunch of tools already in use for doing continuous integration, logging, and monitoring. So we had to somehow fit all of this serverless in with these existing tools. Luckily, the serverless framework was very simple commands, allowed us to very easily integrate these. So we'd have a Lambda picking up the logs and writing them off to the logging tool, or the continuous integration tool could just run these very simple commands to automate your deployments. So what I've sort of been getting at here is I've managed to implement a reusable integration pattern in the enterprise using serverless.
Right. Just to sum up quickly, rather earlier, working collaboratively with our cloud security team, we could achieve significant innovation. Serverless integration means you can build some awesome stuff without needing a heavy integration platform. And operations is way easier without infrastructure. Thanks.